Hello again and welcome to the Calculus Studios of Room 242. This is Mrs. Favorite bringing you today 5.2 Day 2, Definite Integrals. This is some more of the same stuff we just did, except now we're going to talk about net area and total area because these can be a little confusing, not really, but a little. The total area is all the area you see on the curve, between the curve and the x-axis. But net area is what the integral gives in calculations, and when you use the calculator to find integrals, you get net area. If the area is below the x-axis, and then it is negative. If it's above the x-axis, it's positive. All right, so that's what net area is. Basically, it says everything you need to know right here in this line, the starred line. If the area is below the x-axis, it's negative. If it's above, it's positive. Now, total area takes into consideration all of the area between the curve and the x-axis, whether it's above and below. Total area is basically the absolute value of the net area. And it's also, we put it in our calculator actually like this, if we have to put it in our calculator. Okay, it does not take into consideration the negative and the positive, okay, like net area does. This is a very, very extremely important distinction. Please look in your book, listen to this again, read it again, understand it. Thank you. All right, so we're going to use the geometry to find the net area. Oh, I don't know if we can do that. But anyway, we're going to go from 0 to pi and pi to 2 pi to calculate the areas. Now, actually what we're going to use is common sense, not necessarily geometry, but a little bit. This curve, a sine curve, is the same above the line up here as it is below the line over here, right? So from 0 to 2 pi, we have a positive area above the curve and down below, above the x-axis. And below the x-axis, we have a negative curve. These two areas are the same. So if this one's positive and this one's negative, our area is 0. Our net area. Our total area would be 2 times one of those areas, right? But our net area is 0. Okay, above the line cancels out below the line. All right, now we're going to use geometry to find the net area, and we're going to use geometry to find the total area. So, this little diagram gives us a couple of triangles. 1/2 base times height. I wrote that backwards from the way I said it. Base times height. So what we're going to do is calculate this area first. It will be positive. And then over here we have another little triangle. And that area will be negative. Okay, so we have negative area here, positive area there. All right, the first triangle, and let's call it triangle 1, is 1/2. The base is 4 minus x. Where does that cross the x-axis? At 4, is that true? Okay, so it crosses the x-axis at 4 as well. So the base is 4, and the height is 4. So area equals this minus the area of triangle 2 over here. So this is 1/2, because it is below the line, that's why we are making it negative. The base of that is 2, and the height of this triangle is 2. So 1/2, 2 times 2. So here we have 8 minus 2. The net area, A net, is 6. Okay? Now, the total area, we're going to take these two and just add them. So area equals 8 plus 2, and that is 10. That is the total area. All right, so there's a distinction. Above the line positive, below the line negative for net area. All right, let's use the calculator. Oh my gosh, you're going to love it. All right, so we are going to use our calculator, Math 9. Now back in the day, we used to have to use this, something called FINT, function integral, and we used to have to put in arguments for numbers for it. But now on our calculators, Math 9, you don't really have to worry about that too much, but if you see it, it means the same as the integral on the calculator. But now, if you just press Math 9, you get this, you get a display that looks exactly like your integral. All you have to do is plug in the numbers and the letters like you see them. Lower level of integration, upper level of integration, and then you have to put in dx. So put in, if you're using x's, put in dx. And most times you will be using x's. All right, and then press enter, and you get 1.872 or 1.871. Either one is great. Okay, pretty simple, and that is your net area. Okay, again, net area is what you get out of the calculator. And let me write that down. This is net area. It does not take into consideration the above and the below. All right, so this one also we'll put in the calculator. So again, we'll put this into our calculator and get a net area. I use the fraction key. So 0.11111, math, enter. Is that a fraction? 1/9. Sweet. I like 1/9 better than 0.11111 because it accurate. And once again, this is net area because we got it from our calculator. All right, last but not least, sometimes we can integrate a discontinuous function, even though this function actually has a little hole in it, at x equals 3, we can find the areas under the curve for this function. Let me draw the graph. Okay, so here's a picture of our graph. This function is a line, and so we have two parts to this function for taking the integral. We have the area under the curve up here of this triangle, and then the other area under the curve we have is the big triangle. Remember, this one is going to be a negative value, this is going to be a positive value. So what we're going to do is add our rectangles to get the net. All right, so the first one is positive, so it's 1/2. Base is equal to a 1 between -3 and -2, and the height is 2. If we plug a -3 into this equation, -5. Oh, I'm sorry, this should be -5. Oops, I locked that into place. This should be a -5. Okay, so anyway, if we plug in -5 in here, I believe that we get a 2. Okay, so that is the area of the first triangle. Now we're going to subtract the area of the second triangle. So this is a 2 plus 6. Across the top is an 8. We'll call that our base. And then this height is -9 or a 9. So we just consider how long it is, the length. So now we have let's see. You know what? This should be a 2. Is that a negative 3? Hang on just a second. Okay, looks like I have another mistake here in the graph. This should be a negative 3. Therefore, my base here should be 2. So this should be 1/2 2 times 2 minus 1/2 8 times 9. Oh, this is 9 times 9. Oops, so this would be 9 since I changed that to 3. This width would be 9. So let's clean this up. Make sure you have your numbers right so you don't run into this problem I'm having right now. Make sure you have your graph right is really what you need. And so anyway, this should be the correct answer. And if you add all that up, you get a negative 38.5, which is expected. It is expected you would get a negative net area because there's such a big space under the curve as opposed to above the curve. All right, so that is the end of section 5.2, day 2. Happy areating. That's not a word.